Hi everyone, in this video we'll be looking at transition elements or transition metals. Okay, they are found in the middle block of the periodic table. We'll focus on two things. Firstly, to describe the typical characteristics of transition elements. And secondly, to look at the catalytic effects of transition elements as well as their compounds. So the appearance of metals, okay, are usually gray in color with the exception of copper over here, which we normally refer to as pink or reddish brown. Let's start with the first property. Okay, I have over here group 1 metal potassium, and in the other columns we have chromium, manganese, iron and copper, which are transition metals. What do you notice in the difference between them in terms of melting point, boiling point as well as density? I think it'll be fairly obvious that your group 1 elements like potassium have a low melting and boiling point and they have a low density. Okay, even your other elements like those in group 2, they would have a lower melting and boiling point compared to those transition metals. The second property that is unique to transition metals is that they form ions with variable oxidation states. So if you haven't learned redox reactions, don't worry. The oxidation states are actually written in the brackets over here. So you just need to learn to read the Roman numerals. So chromium 3 would mean that the oxidation state is +3. Potassium dichromate 6 would mean that the oxidation state of chromium is +6. For manganese, you have +4, +7. Okay, iron 2, iron 3, copper 1, +1, copper 2, +2. Yeah, so they have variable oxidation states because the ions can take different oxidation states. It can be +3, +6, +2, +3. It depends on the elements. If you compare that with a main group metal, let's say calcium or magnesium, okay, it's quite straightforward that when we say the calcium ion is always Ca2+. So when we name the transition metal compounds, we don't just say iron chloride, we say iron 2 chloride, iron 3 chloride. Another characteristic property of your transition elements is that they form compounds that are colored. Okay, so I want to emphasize this word. The compounds are colored, not the metals. So chromium 3 chloride is a compound, green. Potassium dichromate 6, orange. Okay, so we have different colors for different compounds, and it kind of corresponds to the different oxidation states as well. Okay, so generally speaking, different oxidation states take on different colors. So you will recall last time when we did qualitative analysis, you would remember some of these colors like copper 2, iron 3. The precipitates or the metal hydroxides have different colors. So here are more examples showing you that in different oxidation states and different ions, so the compounds containing these ions will take on a different color. So at this point, I thought I want to pause the video and show you the colors of manganese. Yeah. So over here, I have potassium manganate 7, which is purple in color. Okay, this is manganate 6, which is green. Okay, then your oxidation state here +4. This is yellow. And +2, that's when you have manganese 2, Mn2+. So where is this useful? Okay, there are many applications of that. One is in making art. In stained glass, for example, how do they color the glass a different color? So you know that glass is mainly silicon dioxide. So they add different transition metal ions to glass to give the glass a different color. Also like to share a story with you. When I visited Japan, right, I actually went to this pigment store. So behind me, you see a wall of pigments that are very colorful and looks very nice. And pigments can be organic or inorganic. So inorganic pigments are generally ionic compounds, and many of them are compounds of transition elements. So you have cobalt blue, viridian green, yellow ochre, red ochre. You can see that they contain transition metal ions. And the different ions that they contain impart a different color to the pigment. So if you're very interested in art and you want to see some connections to science, you can go online and search for this place called artistpigments.org, and you can see what kind of art pigments or paint pigments can be made with different elements. So when you click on it, right, it will tell you where you can find those elements in different kind of paints. So over here is an artist who makes paint by blending the pigment with oil. She's making a green paint out of copper 2 carbonate.
Today we're talking about malachite, that ghostly cool green that's been used in art and cosmetics for over 8,000 years. It gets that beautiful blue-green from copper carbonate, which if ingested can cause severe copper poisoning, and even death if you were to eat enough of it. But what in my opinion is the most interesting fact about this pigment is that it was used in the most stolen painting in history, the Ghent altarpiece.
Okay, finally, another characteristic property of transition metals is that they are good catalysts. Okay, and this is transition metals and their compounds, so both of them. I'll share with you some examples. Okay, we'll probably encounter some of this when we go through some of the topics in our syllabus. Okay, first will be nickel. Nickel metal is used in the hydrogenation of alkenes. This is when we'll cover this in organic chemistry. Finely divided iron is used in the manufacture of ammonia gas in the Haber process, which we'll cover in a later chapter as well. Manganese 4 oxide is the black powder that you added to hydrogen peroxide to speed up the decomposition of it. You probably used this in the lab when we were trying to generate oxygen gas to test for oxygen. Vanadium oxide is used as a catalyst in the contact process. This is not in syllabus, but it's the process that is used to manufacture sulfuric acid. So you see, it's not just the metals, but also their compounds that are good catalysts. Okay, I'll show you some more examples. Here's an experiment showing a copper coin used to catalyze the oxidation of acetone. Acetone is the chemical you find in your nail polish remover. Okay, let's take a look.
Got a penny, a beaker, and some acetone. Now watch what happens when I heat the penny up and put it right back in the beaker. I used a torch to heat the penny till it glowed red hot. Notice how it continues to glow red hot even though I'm not applying any more heat to it directly. So what you see here is copper acting as a catalyst. It's oxidizing the acetone. And it'll keep doing this until the acetone runs out of the beaker. Yep, still going. It puts off quite a bit of heat. I can feel it through my nitrile gloves.
So what a catalyst does is to speed up the rate of reaction. Okay, so on the surface of the copper, that's where the molecules will gather, bonds will break, bonds will form, and having the catalyst makes the reaction go faster. And at the end of the reaction, right, the catalyst remains chemically unchanged. Here's one more example. This is cobalt 2 chloride. Okay, cobalt 2 chloride is pink in color, and in the beaker I actually have hydrogen peroxide and potassium sodium tartrate. Now, the reaction between the two of them is actually very slow. Watch what happens when you put the catalyst, which is cobalt 2 chloride, inside. And as you watch the video, think about what evidence shows that the catalyst, number one, speeds up the rate of reaction, and number two, remains chemically unchanged at the end of the reaction. Okay, let's take a look. One reason why transition metals and their compounds are good catalysts is because they can form ions with variable oxidation states. So over here, we start off at +2, right? Which is pink in color. You saw a color change to green. That's when your cobalt takes on the oxidation state of +3. And when the reaction finishes, it goes back to pink again, which is when it goes back from +3 to +2 in oxidation state. So the cobalt ions, which are the catalysts, remains chemically unchanged, but they speed up the reaction because you saw a lot of bubbling that happened. I would like to pause here for you to try the checkpoint questions in the notes first, and then I'll go through them with you. Okay, so pause the video. Once you're ready, you can continue. Question 1 states that vanadium has variable oxidation states and it forms colored compounds. Okay, this is a clear hint that it is a transition element. Okay, you can see that in different oxidation states, you have different colors. So if a vanadium compound in solution changes color from violet, which is this, to blue-green, which is this, reduction has taken place. This is actually incorrect because you are going from +2 to +3. The oxidation state increases. Okay, oxidation state increases is oxidation. If you haven't learned redox reactions, don't worry about this. Okay, so it is not reduction, it should be oxidation. Vanadium has a high density. Okay, that's true because it is a transition metal. Vanadium compounds are likely to be catalysts because transition elements are likely to act as catalysts. Vanadium, being a transition metal, should not have a low melting point, it should have a high melting point. So the correct answer here is B. So question 2, we are supposed to identify the different transition metals, either as elements or compounds. So let's count. We have nickel, okay, 1, chromium, 2, antimony is not, copper is 1, platinum and rhodium. So we have a total of 5. Answer is C. Okay, question 3. Option A, we might be tempted to select A as the correct statement, but because it says or, okay, so be very careful. There are catalysts which are not transition elements as well. Okay, enzymes are one example that can act as catalysts. All colored compounds contain transition elements. Again, that is not true. Transition elements conduct electricity because they have free moving electrons, okay, not variable oxidation states. High melting points due to strong electrostatic force of attraction between the positive cations and the sea of delocalized electrons. Okay, so this is correct. So let's review the learning objectives. Transition elements have high melting points, high density, variable oxidation state, and they form colored compounds. And it is both the elements and compounds that can act as catalysts. Okay, so with that, that's all for this video. I'll see you in class.